Okay, the next issue is how to evaluate location alternatives. It means that if you have different choices between a location, more than one locations are in view of you. So how to select one of them? It happens in organization when organization take decision to shift or to have new location. So they may have a different alternative, different choices, and among those alternatives they have to decide about one. So how to choose or how to select one out of many location, it needs to evaluate, and here the evaluation process is explained, and I would like to explain three methods in evaluation of location alternative. The first one is location cost volume profit analysis, and by cost profit volume analysis, if it is being termed other way, it can be called uh, break-even analysis. The economic comparison of the location alternatives facilitated by the use of the cost profit volume analysis, and the analysis can be done numerically or graphically. The graphical approach will be demonstrated here because it enhances understanding of the concept rather to spend time on the mathematical, because it would take too much time and it requires some kind of a basic mathematical tools. So we are not having that scope here. So I'll be just explaining the graph, and after that the procedure for locational cost profit volume analysis involves three steps. Number one is determine the fixed and variable cost associated with each location alternative. It means that every location would be having definitely the fixed cost and the variable cost, and the difference between these two costs, very well. And after that, the plot the total cost line for all location alternatives through the same graph. In the same graph, you will be drawing this total cost for all the locations, and then determine whether the location will have the lowest total cost for the expected level of output. Alternatively, determine which location will have the highest profit. So it's very simple to choose that location which have the lowest total cost curve and the high rate of profit. So that location would be definitely would be the required one. The method assumes the following: fixed costs are constant for the range of the probable output. Variable cost is linear for the range of probable output, and the required level of output can be closely estimated, and only one product is involved. So all these four conditions should be there for decision. Now there is an example. Let's say if we are having four location A, B, C, D, and as I've stated that if you have more than one location, then you must be having fixed cost per year and variable cost per unit. So there it is been given. So for location A, fixed cost is $250,000, and location B it is $100,000. For location C it is $150,000, and for location D it is $200,000. While the variable cost, obviously variable cost would be different in all the locations. If you are producing on location A, then each variable cost of each item would be $11. And if you are producing the output or the product on location B, so that would be having variable cost as 30. It means that variable cost is high. Probably this location is far away or having some more costs. Anyway, and if you are producing same product on the location C, that product cost $20. And if the same product is produced on location D, then the variable cost is 35. So for each location, I'm having fixed cost and variable cost. Now, we will plot the total cost line of all these locations on a single graph, then identify the range of output for which each alternative is superior, and if the expected output at the selected location is to be 8,000 unit per year, अगर आपका output 8,000 unit per year तक आए, which location would provide the lowest total cost. So the objective here is to have 8,000 unit of output out of these locations. So now the question is that these 8,000 units per year, where these units to be produced out of these four locations. So definitely, if these 8,000 production uh, uh, is produced at the least cost, so that would be our choice in location, or having maximum profit. So that would be our basically the required location. So solution. First of all, we have to plot the total cost line, select the total output that is approximately equal to the expected output, that is 10,000 per year. Compute the total cost for each location at the level. So total cost obviously is being computed by summation of fixed cost and variable cost. So if you are producing 10,000 unit per year, so 10,000 unit per year on the cost, variable cost of 11, so that is being multiplied plus the fixed cost, it makes $360,000. Similarly, the 10,000 similar level of output, if it is produced on location B at $1.30, so we will multiply that and plus the fixed cost, that makes $400,000. And similarly, 10,000 same output is produced at the rate of $20 multiplied plus the fixed cost, that makes $350,000. And then the last location B, where the same output 10,000 units are produced at the cost of 35 per unit, variable cost multiplied and plus this fixed cost, it becomes $550,000. So all these total cost is being calculated, and now in the graph all the costs are being drawn, and you can see that A location is having that kind of a total cost, location B is this kind of total cost, D is this, and C is this. And now if you see that first point here, where the B and A are being intersected or crossed, it means that till that point B is superior because the B cost is least cost. You can see the very much minimum and least cost is of B location. But if you can surpass 5,000 production, then the C is superior, because now you can see the C total cost is least. You can see the orange line. And after this 11,000 almost production, then the A is having the least total cost. So now it's up to you. Plot each location we have plotted at out all these cost on the graph. The approximate range for which the various alternative will yield the lowest cost, as I said that A, B, C, and D, the lowest cost. And thus for B and C, because obviously we have to see the output required, what we want to produce. So B and C, they both are equal at that point where the output is almost 5,000 units. So this fixed cost plus variable cost into Q is equal to fixed cost plus variable cost into Q. B and C point are equal at the amount of 5,000 unit per year, where the A and C are being equated here on, I think it is 11,111, So A cast, C cast and A cast is this. Where this calculation come from? Here it is. This is fixed cost plus variable cost into output. So this is actually the equation. And now you can see that where the B and C were joining, the output was 5,000 units, and where A and C are joining, output was 11,111. From the graph, you can see that the 8,000 unit per year location C provides the lowest cost. So you can see in the graph, uh, between these lines, where we want to produce $8,000, oh sorry, 8,000 unit. So that 8,000 unit is being can be produced at least cost on plant or location C. So that location C would be very better according to this principle. The second method is a factor rating. There are some steps are involved, and following procedure is used to develop the factor rating. Determine which factors are relevant. Location of market, water supply. If you remember that we have discussed a lot of factor associated with the type of business. But when you listed the factors, then assign a weight to each factor that is indicating the relative importance. Then decide the common scale for all factors from 1 to 100 to set the minimum acceptable score if necessary. Score each location alternative, multiply the factor with the score, and then sum it up and choose the location with highest composite score. So how does it take place? It is being explained here. So it is example number 7, and which is explaining the uh, factor rating method. Here you can see that these factors are relevant factors which were listed, that is the proximity of existing stores, that in that area how many other stores are there. Then the second very much important factor is traffic volume. And the third is rental cost, what the rental cost of location is, then the size of the location, then the layout of the location, and the operating cost. So these are the factors. They have been listed by the manager, they have been listed by the experts. Then we have assigned the weight. We have assigned the weight. You can see that all weights, if they sum up, their total would be equal to 100. So we have assigned the weight out of 100 according to the importance. So here the most important is rental cost. 40% importance is given to this. After that, the second most important thing is layout. What is layout? You can see the previous videos. And the third, the important thing is operating cost, which is 15%. Fifth important things are size and proximity of to existing stores. So this is the 10%. And the least important factor is traffic volume. That is 5%. So weight is given. Who gives the weight? The experts, the managers, brainstorming, and all such kind of practices, they would define weights. Then alternative. We have two alternatives here, location 1 and location 2. And in location 1, the score is being given to all of these factors. At location 1, proximity to existing store is carrying 100% weight. Now it is not necessary that this, because it is not percentage, it is just marking. So proximity to existing store, location 1 is taking 100 marks for this particular factor, while location 2 is carrying 60 marks for this proximity to existing store. Traffic volume is equal in both locations, so that's why 80% marks is given to both. Rental cost is high at location uh, 2 and sorry, location 1, because rental caste is caste, and lowest caste or lowest marks are good, and highest marks are not good, obviously. So that's why high caste is carrying, sorry, high rents are carrying lower marks, or low rents are carrying high marks. So location 1 is having expensive in rental, and location 2 is having some relaxed rents. Size, obviously location 2 is having bigger size, 92 scores is given to it, and location 1 is given 86 points. And layout, in layout, location 2 is very much important. Location 2 is very much good, uh, scoring 70 points, while location 1 is scoring 40 points. And operating cost, again, location 2 is having high number. It means that the location operating cost is low, and 80, it means that operating cost is high. So who give these scores and these marks to these locations? Again, the experts, the managers, they actually put their information into this stream, and they decide about the weights and scores. And after that is quite easy, that multiply each alternative to the weight. 100 by 0.10, so that become 10. So all the alternatives, just scores are being multiplied by the weight for each alternatives. So that is for alternative 1, 100 into 0.1, 80 into 0.05, 70 to 0.40, 86 into 0.1, 40 into 0.2, and 80 into 0.15. That becomes these figures, and the sum of it is 70.6. Similarly, location 2 is also multiplied by the weights and summed up, and the total is 82.7. So finally, 82.7 is higher than the 70.6. So location 2 is carrying higher score. So you have to choose location 2 here according to this practice. So this is the second method of factor rating. After that, center of gravity method is the last method. Now, how this center of gravity method works, rather explaining this slide, I would like to go direct to the application. You can see that the map is being taken. If you remember, or if you study this thing, so you will see that first of all, you have to get the geographical map for your locations. So there are simple locations: D1, D2, D3, D4. These are the different uh, destinations, different options. And when you have located your geographical points, and after that, you have to scale on x-axis and y-axis from 0 to 10 and from 0 to 10 on the both axes. And after that, obviously, you have to calculate the closest point or closest location according to your requirement. So that would be a good choice. So let's see how it can work. It is an example. Determine the coordinates for the center of gravity for the problem depicted in the figure 8.1. See, you can see that. And assume that the shipment from the center of gravity to each of the four destinations will be equal to equal quantities. It means that equal quantities are being to be shifted to these four locations. So what location would be more beneficial for the process? So if you have uh, managed with your geographical map, Here you can see that we have uh, plotted all the destination, four destination D1, D2, D3, D4. That is geographical locations. We cannot point it out by ourselves because they are on the map. And after having these points, dots, we have a scale from 0 to 10 on the y scale, 0 to 10 on the x scale, and we have to calculate the mean of x and the mean of y. How? The mean of x and mean of y, here, these are the formulas where we can calculate the mean of x and mean of y. So summation x into q, quantity is being given to us, and x, obviously, the scale is being established by u. So it is quite easy. So this is destiny or one, destination one, x2 and 2. You can see that here it is 2 and 2, 2 on x-axis and 2 on y-axis. So that's why it is 2 2 pair. And d2 is 3 5, 5 for x and 3 for sorry, 3 for x and 5 for y. And d3 is located on 5 4, 5 for x and 4 for y. And d4 is located on the 8 5, 8 for x and 5 for y. And these scale as being uh, uh, established by your choice. So here 2 2 3 5 5 4 8 5, they are being given. The total of x is 18, the total of y is 18. So just having a simple mean, that is 4.5 and 4. Hence the center of gravity 4.5 and 4, which place is just uh, 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 west of the destination 3. So you have to see that this mean of x and the mean of y, from which location this pair is nearby. So 4.5 and 4 is located here. So this location 4.5 and 4, the mean of x and mean of y is located here, which is very nearby with destination 3. So destination 3 would be our choice by this method. This is another example with the quantity. Same process is there. Obviously, I will not explain again. So this is the method for evaluation of locating alternatives. So this is all about the location planning. Thank you very much.